Hi, Miss Millender here. We're going to talk about pressure. Feeling a lot of pressure. 14 pounds per square inch, actually closer to 15 pounds per square inch. All right, let's go. So the first question you need to answer is what causes pressure in the first place? Where does it come from? Well, it comes from the gas particles colliding with each other, as well as everything in the container and the walls of the container itself. So it's the collision of particles. And if you think about that, that makes sense, because if there are billions of particles smashing into you or other stuff, it's going to push it. So the question then is, what has to happen in order to change the pressure? Well, you have to change the collisions, right? So something has to happen to change the collisions in order to change the pressure. And so what then can you change about the collisions? You can change the number of collisions, more or fewer, or you can change the force of the collisions. Do they hit with a lot of force, or is the hit a little more gentle and therefore there's less force? So all of these things you need to keep in mind. Pressure is caused by collisions. Collisions happen against the air particles themselves, the walls of the container, and then anything else in the container. And then you can increase or decrease the number of collisions or the force of the collisions. So, what can you do to change the force of the collisions? Well, there are three ways. You can change the speed of the particles, the number of particles, or the space available for the particles to move around. Now, hopefully you recognize some of these as definitions to terms we've already used this year. Speed of particles, average speed of particles, what's that the definition of? Temperature, kinetic energy, there it is, you got it. Number of particles, if you increase or decrease the number of particles, what are you changing? Mass. And if you increase or decrease the space available, what are you changing? Volume. And if you remember from not so long ago, if you look at mass and volume together, what are you actually looking at? Density. But we're not going to use the term density in here because I really want you to focus on what's changing, the mass or the volume. If you say density, then it could be either of those. So just so you know, density is involved, but we're not going to use it. Okay, just as a quick review, what units do you use with temperature? Degrees Celsius or Kelvin? Number of particles? Grams or kilograms, there's your mass. And the volume? Milliliters or liters. Wonderful. So the question is, how do these change the collisions? Which, again, there's logic behind this. This is not something you should have to memorize, but if you visualize what's happening, it makes complete sense. So what happens if you decrease the speed of the particles? Well, you're going to get fewer and less forceful collisions. So there are fewer collisions, and the collisions that do happen are less forceful. What if you increase the temperature? There will be more collisions. Oh, and more forceful. I better fix that. All right, let's go to number of particles. What if you decrease the number of particles? There'll be fewer collisions because there are fewer things to crash into each other. And if you increase the number of particles, there'll be more collisions because there are more things to crash into each other. And finally, volume. What if you decrease the amount of space that the particles have to move around? Well, there are going to be more collisions because you have the same number of particles but in a smaller space. And what if you increase the volume? There'll be fewer collisions because now you have the same number of particles in a bigger space. So, things to keep in mind, things to remember. Pressure can only push. So, when you're looking at things moving, because remember you can't see the air, but you can see the effects of the air on other stuff. In whichever direction things are moving, the push is from that same direction. Okay, so if you see a balloon getting bigger, for example, where's the push coming from? It's coming from inside the balloon. What if you see a balloon shrinking? Where's the push coming from? It's coming from outside the balloon, pressing it into a smaller space. Suction, then, although we have been asked to strike it from our vocabulary, is really just an area of higher pressure pushing against an area of lower pressure. Pressure cannot pull, so there's no such thing as suction. And so we heard the explanation from Julius in the video that, in fact, suction cups maybe should be called low pressure cups or something, I don't know. But anyway, I thought that was kind of cool, and bring any questions you have to class, and thank you very much.